Okay, welcome to part 3 of the Rust tutorial series. Today we'll be talking about understanding Rust, Python, and importing libraries. So, most of our code, like pretty much 80% of their code, is in Python. And we also have automatic documentation for all the software. So, for example, if you go to go over here, you can check out the website. Your website is automatically built for all things that gets pushed to master, because there's a action called like deploy to GitHub pages, and then you can just simply go to code API, and you can see that these packages are the ones that we're focusing on: common object detection, object location. You can use this as a reference. This will show you the different types of functions in this class. And if you want to check out the source code, there's also a link here. It will show you the exact source code. So all of this is automatically done, and it's convenient. So for example, if I want to find this exact file here, function here, one useful shortcut, Control-Shift-N, allows me to navigate to any single any file I want, except this is not a file. This is, so I can click on symbol. It'll take me to that symbol. So preferably for most of the Python stuff, it's better to make sure you follow the standard and have a type hint for the object, and having this equal sign, meaning it's a default value. If you put the type here, it will help with the code hinting a lot. After that, you want to create a function, a description of the function. Sometimes you don't, but a convenient way to do this is just to type 3 of these quotes and then click enter, and it will automatically do it for you. And make sure that there's a space between the description and the parameters, otherwise it won't render properly on in the documentation. Now, another thing I want to mention: all of these packages that I've mentioned here, all of them are both Rust Python packages, and they're also setup.py packages. So what this file does, it renders this package, soccer common, as a package, which can be used in a different location. For example, one of the most common things in robotics is a transformation, and then I have this big transformation class. If I go to PyControl, notice that these folders are blue. What I did here is I just go right click and I mark directory as sources roots. If you don't mark it as sources roots, you won't find the files there. So for example, in the navigator, I would use this transformation class. So I just call soccer common dot transformation import transformation. So this file indicates this file, and this indicates this, and over here this indicates what I'm importing in there. And basically for this, if you turn everything into a package, you can have any Rust code importing any other Rust code, and this is very convenient as it saves the need to create multiple transformation and functions that are used among different types of Rust packages. Okay, next, moving on to testing. So each of these packages has a test. Let me just do a simple, easier one for now. A test. Any file that's prefixed with test is automatically marked as a PyTest, and it's run in the CI. So for example, I can just go on here and I click run the test. It will run the test. One thing about these tests is that sometimes they don't show any output, so you want to go here, click edit configurations, and push -S, and this will make sure that the test, when you run it, it will print information and such. You can also right click here, you can click debug, and if you're running a test, and then it will have a breakpoint. And to debug, for example, I have the variables cam angle. I want to know what the current cam angle is. It sets here. If I can also use this calculator here, click evaluate, I'll get the cam angle. I can type any sort of expression I want here, to get more information, and even run like entire functions here. It's very useful. And then you can click on the step over, step into, step, mostly these two buttons here. This will, you can see as the variables have changed. If you want to jump to a breakpoint, you put a breakpoint there, and then you click on the resume program. It will jump to the same breakpoint. And if you're done, you can click on hit the X stop button to indicate that I'm done with the test. Some of the tests have visualization, some don't. For example, if I go here, test walking, there's some of my have explicitly have a variable saying if I want to display anything or not. I can set that to true, and I can run the test. As you can see, it's succeeded the test and it's passed. One thing about the tests that we use, a lot of them use PyTest, which might be quite daunting in the beginning, but basically what PyTest does is it allows you to include, add an object in the test, like a fixed object, and indicates it's a navigator. I click on here, and this is a PyText fixture. So before I even run this function, it first evaluates this fixture, and it creates this object called a navigator Ross, and then it returns using the yield. So let me just give you a demo. If I put a breakpoint here and I put a breakpoint here, press debug. Yeah, so it will first reach the walker here, then it will go here, and then it will return the navigator before it actually goes into the test function. And that's basically a PyTest. These extra decorators allow me to make the PyTest more fancy. For example, this decorator allows me to run the test for both BES1 and BES3. Another cool thing you can do, you can run every single test inside the entire folder. So you can go past this in Soccerbot, and you can run, and then it'll start running all the 57 tests that are in the test folder. For that one, you just press space. Just run every single test one by one. It's kind of slow, so I'm going to stop here, and then you can see a summary of all the tests have been run. So for example, if I put parameterize BES1 and BES3, it will run the test for both BES1 and BES3. I think that's about it for the Rust and Python tutorial. I guess if there's anything that's not clear, please message in the group channel and I can elaborate it for you. Thank you for watching this video.